All right, let's dive right into one of the wildest ideas in all of science. We're talking about how black holes, the most extreme things in the universe, can actually bend and stretch time itself.
Just let that sink in for a second. It sounds like something straight out of a movie, right? You go on a quick trip, maybe it feels like an hour or so, and when you get back home, everyone you know is years, maybe even decades older. It seems impossible, but this is a real thing that can happen according to the laws of our universe.
So the big question is, how? How on earth can your clock tick at a totally different speed than someone else's? This isn't some kind of optical illusion or a trick, it's a fundamental part of how the cosmos works, and the answer is all about gravity.
Okay, so the fancy scientific term for this is gravitational time dilation. And it all boils down to a really mind-bending concept. Time isn't universal. It's not some cosmic clock that ticks at the same rate for everyone, everywhere. The speed of your time, well, it actually depends on how strong the gravity is where you are.
To put it simply, here on Earth, we're in what's considered a weak gravitational field. So time moves along at what we'd call a normal pace. But the closer you get to something incredibly massive, like a black hole, where gravity is just off the charts strong, time itself starts to slow down for you, a lot, compared to someone watching from far away. Now, to really get your head around why this happens, you kind of have to forget the old idea of gravity as just a force that pulls things down. See, Albert Einstein came along and completely changed the game. He showed us that space and time are actually woven together into this one thing, a four-dimensional fabric called space-time. And gravity? That's just what we feel when that fabric gets curved or warped by something heavy.
The classic analogy is to think of space-time like a giant, stretched-out rubber sheet. If you put a bowling ball on it, it creates a little dip, right? That's kind of like the sun's gravity. But a black hole isn't a bowling ball. Oh no. It's more like an infinitely heavy little marble that punches a deep, almost bottomless funnel into that sheet. It creates this incredibly steep curve.
So what does this have to do with time? Well, as you travel deeper and deeper into that curve, closer to the black hole, the fabric of space-time itself gets more and more stretched out. And since time is part of that fabric, it gets stretched out too. That means for an astronaut down in that gravity well, the watch on their wrist is literally ticking slower than a clock back home on Earth.
Now, if this still feels a bit abstract, I'm willing to bet you've seen a perfect example of it in a pretty famous movie. The film Interstellar actually uses this exact, very real physics as one of its main plot points.
Remember that scene where the astronauts land on the water planet? The one that's orbiting super close to that giant black hole, Gargantua? To them, they're on the surface for just about an hour, rushing to get things done before a giant wave hits.
But, and this is the kicker, because they were so deep inside that massive gravitational curve, their one little hour on the surface was equal to 7 long years passing for the astronaut who stayed behind on the ship, and for everyone else back on Earth. It's an absolutely powerful and heartbreaking way to show time dilation in action.
So if you take just one thing away from all of this, let it be this. Gravity does way more than just keep our feet on the ground. It's a fundamental force that literally shapes the universe and can actually change the speed at which time flows. Realizing this just completely changes your perspective on reality. It leaves us with this huge, amazing question to chew on. If something as basic as time can bend and warp, what other incredible secrets is the universe still hiding from us, just waiting to be discovered?